Hello, this is a lecture for computer numeral control. So for this lecture, mainly I'm going to discuss the fundamentals of numeral control technology and also talk about one major machine that is used in manufacturing, which is computer numeral control machine or CNC. Some application of CNC as well as how the positioning system works in the CNC machines. And lastly, I'm going to talk a little bit about how to program in CNC machines. First, computer numeral control is a programmable automation. So some of the mechanical actions will be triggered by computer programs or coded data. So basically, when you have a mechanical action or and then we just need to tell the machine where to move, how to move, from which position to what position and do what, right? So basically this is how the numeral control works. And some of the basic components for the CNC is that it includes program instructions. So basically, the instructions of to tell the machine what to do, and this the second component is the machine control unit. So basically, it's a computer system that processes the program instructions and also tell the actuators or the machine system, how to move the tools and the work tables. And lastly is processing equipment, which is actual actuator that performs all the actions from the program instructions. And so for the coordinate system, usually there are two different sets of the coordinate system. One is the typical work table of it's processed for more of a flat and block type like parts. Another one is the rotational parts, and it can be it can rotate the parts and then do some of the machinings. For example, turning operations. We can take a look at the video.
Hi folks, let's machine this V8 engine block Haas VM3 with the TR200Y 5-axis trunnion. Sit back, relax, and enjoy.
So the part is fixed on the work table, and they can see that is the flat kind of a coordination system. It's the facing operation to remove the materials from the workpiece. Some of the milling operation. So this one has a rotation behavior. So it rotates the part. This is also a milling operation. You can see that for this operation, the machine tool is not moving. What is moving? It's the work table, right? The work table that is holding the part is moving. So the part is moving. Move forward.
The best 5-axis machining centers are built right here in the USA with unmatched rigidity.
So the reason is using a lot of coolant is because one thing is to remove all the chips from the workpiece. Another reason is to cool both the workpiece and also the machine tool, because during machining actually the temperature at the machining tool bed is very high. Alright, so this is the first video, and then now let's look at rotational part coordination system. So we're going to use a turning operation to demonstrate.
In straight turning, the tool is fed parallel to the axis of the work to reduce its diameter so that the final diameter is the same at each end. Removing a significant amount of material in one pass is called rough turning. The final lighter cut that creates a smooth surface finish is called finish turning. Taper turning produces a taper along the axis of the workpiece. Tapers are produced by offsetting the tailstock from center line or by using a taper attachment. Short, steep tapers can be turned using a compound rest. Contour turning, or profiling, was formerly performed by having the single-point cutting tool trace a template of the desired profile shape. This has largely been replaced by CNC turning, in which the desired contour is simply programmed into the machine, which directs a cutting tool to cut the contour.
So the part is actually
Forming
rotating
is
very
alternative
fast.
for generating complicated shapes. The tool having the desired form or geometry is advanced perpendicular to the axis of rotation, reproducing the tool shape in the workpiece. Forming is commonly performed on automatic screw machines. Chamfering eliminates sharp corners from a workpiece and is a good safety measure. Typically, chamfering breaks corners at a 45-degree angle. Grooving creates a groove or recess using a tool that is usually the size and shape of the required groove. Some grooving tools can also widen a groove by traversing side to side after plunging into the workpiece.
All right. Next, so let's look at the motion control systems. So there are two different kind of motion categories. One is the point-to-point system. The other one is the continuous path system. So the point-to-point system means the tool actually moves from one point to another point as a straight line, right? And while the continuous path system is also a contouring system. In this case, when the tool actually goes down to machine, it will when it moves from one position to another, it's also doing the operation. Right? It is also doing the operation. So this is the more continuous path or continuous machining operation. Well, the point-to-point means if once you finish one point of the operation, then you retract the tool and then move to the next point and then do another operation. So this is the difference between the two systems. Someone say that when the machine tool is moving from one point to another, especially when the machine is actually doing a radius shape, how does it work in the control system? Well, there are different ways. For example, you can see in this figure. When the machine moving through circular shape, what happens that because the numbers we tell the machine from one position to another should be our segment, right? For example, move 1 from 2. All right. Between 1 and 2, there are actually numerous numbers. So it's hard to get all these numbers. All of it is just impossible. Then we have to use some of the ways to make enough accuracy so we can make analogy that is similar to a radius. So this is how it works. They call it circular interpolation, right? For example, the inside, you can see the dashed line. So this is the inside tolerance, and the actual curve is this one, and also the straight line segment approximation is actually what the machine tool is moving. So as long as those straight lines that the machine tool is moving are within the actual curve and the inside tolerance, then we are good. Right, so we can actually create a line or create a shape that is pretty close to a circular shape. So this is how it works in a motion control system as that. Another is we set the tolerance at the outside circle, right? So this is the tolerance. While for the inside, we set inside tolerance. In this case, if the tolerance is outside, then what happens is, as long as the curve is within, right, is within a tolerance as the actual curve, then we are good, right? Then we are good. You can see all the actual all the straight lines that machine tool moves are all within this range. Well, the inside and outside are, when we are defining tolerances, that we want to keep the tolerance as one side. What about if we have two sides of tolerances? For example, we have a limit for upper dimension, and also we have a limit for lower dimension, right? So in this case, we need to define two tolerances, this tolerance and also this tolerance. So we call it tolerance band. So in this case, we need to make sure that all the straight lines that the machine tool moves are actually within this tolerance band. So this also can make the the curve shape movement of the machine tool. And so when positioning of the tools, there are two different positioning systems. So one is the absolute positioning, and the other one is incremental positioning. So absolute positioning means we are using the absolute values of the point in this axis system. For example, this point, right, is 2020. This 2020 is relative to this original point 0, 0, right? So when we say, okay, let's have the machine tool move to this point, we just tell the machine to move to 2020. All right. If we want to further move the machine tool to 4050, this point, then we just tell the machine to move to 4050. So this is the absolute positioning system. Well, if it is the incremental positioning system, after the machine tool have moved to here, what we're gonna tell? We tell the machine, okay, you're gonna move along the x-axis of 20, right, and also along the y-axis of 30, right? So this is the incremental positioning system. We need to specify the move as 20 and 30 instead of tell the machine machine tool go to 40 50. So this is the incremental positioning system. And some of the features of computer numeral control or CNC, usually CNC, it has computer system. They can actually store a lot of programs for different parts and also for different operations, and also you can edit the part program from the machine control software, which is on the CNC machine. And let me see what else I can. So the CNC machine can also have some adaptive controls. For example, when we are machining a part, they actually have some sensors to sense either the distance or when the machine tool actually moves to a certain certain distance along the axis that is can pose some of the dangerous behaviors or actions, then the machine will actually retrieve by itself or stop by itself. So those are kind of the adaptive control it can have in a CNC machine. And also, here is communication interface. The operator, you can work on the interface and then tell the machine what to do. Either you can program it itself, or you can do some manual controls as well. Here, this is also interface where you need to upload the program, download the program, and also make some of the start and end operations. So the CNC control unit is usually basically is like a computer, right? So it has a memory, it has a CPU, as well as an interface, and then on the other side of the machine, which is the main machine actuator, they have the machine tools and also have some sequence tools for either coolant or fixture clamping or tool changer. Those are some other actions that are included in the CNC machine as well. And so CNC also have numeral control also have a little bit of history, that when it started, it really started from the direct numeral control, which is use one very direct command or program to tell the machine what to do, without a lot of feedbacks and also without a lot of adaptive controls. So, and these are called a direct numeral control. And later, when the network starts, so we can actually use one central computer actually to control multiple machines at the same time through telecommunication technologies. And so all these CNC machines actually form a network, and we can use one single machine to control of those. In terms of some of the applications for CNC, it can be many different kind of types of machinings. For example, milling, drilling, turning, boring, and grinding. These are common applications. And if it is CNC, we call it the machining centers, right? Either turning center or milling center. So typically, if it is CNC, it only has one single operation. So either it's a drilling, or either it is a milling, or it's a turning. But in some of the advanced CNC machines, they actually can include several operations at the same time, because it have different holding systems, and also there are more axes, right? You remember when we were talking about turning versus flat table or setup, it's more of the axes setups. Some other processes, especially related to the metal working, are the punching, bending, thermal cutting, or wear, EDM, and also welding. And these are some of the pictures about machining operations. We look at the turning. We also look at the milling process from the video. You're familiar with the drilling. Also probably familiar with the grinding as well. So these are very common, machining operations in manufacturing, especially when you are working with metal materials. And CNC machines actually originally started when we are doing those machining operations. And different axes for CNC machines. Sometimes they can be multiple axes, like 3 axes, 4 axes, 5 axes, 6 axes. Sometimes you may have 8 axes. with more axes, actually the CNC machine's capability is higher, and because, for example, with this work table, right? With this work table, and if there's no if this work table cannot if this round thing cannot rotate, it only has 3 axes, right? But if it can rotate, it actually have 4 axes, not only just X, Y, Z, but also this B, right? So the rotating axes. So this is 4 axes horizontal milling machine. Well, if you want to add more axes, so maybe the work table can lean for another angle, so that can be another axis. And this is what the setup inside the CNC machine. This is the outside. You have some safety doors, access doors, safety panels, and also some of the viewing windows. And you can see if it's a real picture what's it here. So this is a control. This is the machine tool unit. This is the control unit. Yeah. And this is compressed air, so you can blow the chips away. And so when do we use CNC machines? Usually CNC machines, because they are automatic, so they have the program, they can just do repeat work again. So it's a very good fit for batch production and also with repeated jobs. And also, machines, they can also do some complex part geometries that we can program in a computer system first, and then just let the machine tool to do those. If it is human operating, it might be a little bit hard, because it might take a long time, and also it's a little bit hard to control the accuracy, or maybe not very consistent with human eyes. And typically CNC machines are working with metal materials, especially for removing material from metals. This is compared to additive manufacturing, or commonly we call it 3D printing. Right? 3D printing, we only add the material where it is needed, or process the material where it is needed. Well, the extractive operations are we get rid of materials from the original bigger workpiece. And some other applications of CNC machines include some rapid prototyping, our R&D, water jet cutting, or CMM, so coordinate marrying machines. So basically, those operations or applications, they all require a coordination system, right? Coordinate system, that is X, Y, Z, and then tell the actuator where to go. So as long as they have that, right, the CNC coding or programming or control is a very good application. And so open loop versus closed loop. So open loop means so usually if it's open loop, we have a step motor. So step motor is usually used with the DC, while the servo motor, usually we have the AC current. And for the closed loop, we have some kind of source of a sensor feedback. For example, this optical encoder that it can measure the distance, where this work table has moved, and then we'll send this information back to the comparator, where you're going to compare the original point to the current point, and then can calculate, okay, where is the machine right now, and then how much you're going to move next. So this is the feedback signal can be used in the control. This is called closed loop control. And if it is a rotation For the measuring the rotational position or speed, how do we measure that? Then usually we use the light source and also the photocell to do this, and then there's the encoder disk. When the encoder disk rotates, what happens is you can see the light, right? Light will be blocked and then goes through again, block and goes through again. So by this kind of speed, how often this photocell receive those kind of light, it can actually create a signal like this, and then we can measure, do some measurements. Block format. So basically the programming of the CNC or the part machining. So what kind of a program format it is? In ancient times, which is very, very, very long time ago, I would say maybe decades ago, when the CNC machine was just started, people start to use those kind of tapes to punch tapes to tell the machine what to do. Then later, people have created those, computer numeral controls, using numbers. So we're now using codes, numbered codes or letters to tell, to describe the program of instruction. So those will be you can see there are letters and also numbers. Use those letters and numbers to do that. Some typical letters we use. So N means it's a sequence number prefix, and G is preparatory words. For example, G00, this rapid traverse move, right, which is to tell the machine where it should go, to tell the tool where it should go at the beginning. To get prepared for machining. And X, Y, Z, these are the axes, prefixes. If it is X0 or X2 or X20, and then Y what, to locate the position. F means feed rate. So if it is a machining operation, then you will need feed rate, spindle speed, right? Those kind of and also sometimes depth of cut in it. So you need to specify the feed rate and also the spindle speed. T means tool selection, because in a CNC machine there's a tool disk and you can change the tools by itself or automatically, and then you will have to define multiple tools. Say tool 1 is what, tool 3 is what, tool 2 is what, right? And then maybe during when you're machining one workpiece, there might be multiple operations that are required with different tools. So the tool change can be automatic. So just specify that in the program. Say, okay, I'm gonna change to T1, and then later I'm gonna change to tool T2. So this is how it works. And M it is a miscellaneous command. So M different M code can be different things. For example, MO3 or MO2 or MAP30. Those might be in the program and then stop the machine. And MO7, that is cutting, turn on the cutting fluid. Those kind of things. And now let's look at one example how this code actually works in here. So you can see this is a drilling to perform 2 drilling operations, and what happens here is now we have a G00. So G00, that is a point-to-point movement, right? And N01 here means this is a code sequence number 1. So it's basically the first code, and this is the second code. And then this is tell the tool to move to a certain position. Okay, which position? This position, X and Y, right? So basically X70 and X70 and also Y30. So the reason they have 2 0 these are 7 point something, and this will be sometimes you might have 3 digits of the distance, like 100 or 100 more. So that's why it reserves the one digit here. So this is actually the 70 and 30. So we can see the 70 70, 30, you get this point, right? This is the first hole. Now we are telling the machine to actually move to this place. And then what? And then MO3, so MO3 means start the spindle. So when you have this, when you move this, to this line or execute this program, this code, what it means is the machine tool will start to spin, right? The machine tool will start to spin. The drilling bit will start to spin. All right. So after it moved to this this place and then started to spin, what happened? And then the second code will be Y60, right? Then I'm gonna move Y to Y60. Means we are keeping X the same, right? X still the same, but I'm moving the Y to 60, right? So this is how it works, right? But in reality, there are some other operations. For example, after you this is just to move the machine tool here, and also you have to go down to a certain distance to drill the hole, and then extract the machine tool to a certain distance above the surface, and then go to the next hole. So there should be actually multiple codes between the two, if you want to machining two holes. Later I'm gonna go through another example to describe this. This is just to explain how those letters and numbers work in CNC, in our G code. All right, some of the common prefix used in the word address format. F is the feed rate, S is the spindle speed, and T is the tool selection, and D is tool diameter. So what diameter of the tool? Because when you are specifying a cutting operation, you also need to tell what is the diameter of the tool, because the tool has its own diameter, right? That's a thickness. When you are programming it, if you are telling the tool from moving from one position to another position, actually the whole machine tool is moving it, right? So basically, as the whole diameter is moving to that direction, right? So when you are doing the program, you need to make offset to make sure that it's actually the edge, right? Edge of that tool diameter actually machines the workpiece. So this is why what the offset works in a tool. Also, the P is a store color radius data in offset register number. It's not commonly used, but M is very commonly used. M is more than miscellaneous code, as we discussed before. And then G word. G is a very common word we use in the G code, and so common ones will be G00, which is point-to-point movement, rapid traverse, and G01 is the linear interpolation movement. So which means you are telling the machine tool moving as a linear position, linear movement. Well, if it is circular interpolation, we are telling the machine tool moving the kind of more of a circular shape, or like a curve. There are also some other G code numbers. For example, this is G20. G20 means we are specifying the values in inches. G21 will be the millimeters. So you can think about that. And there are some other G codes here. Some of the common ones will be G90, G91. So if you specify G90, that means you are using the absolute coordinates. If you are using G91, that will be incremental coordinates. And another one will be G94, 95, G98, and G99. Those are more of a machining or parameters. For example, G94 is talking about the feet per minute, right? In drilling and milling. G95, you specify the feet per revolution. Feet per revolution means, when the machine tool spins one round, how much, how much it moves at its direction. So which is the axis it spins along that direction, how much it moves. So that's the feet. Well, in terms of the M, so there are common ones like M00, that is a program stop used in the middle of the program if the operator want to, restart the program, the machine later. Also MO2 is in a program machine stop. Another will be M30, which is also in a program machine stop. So sometimes you can use either one. And MO3 will be start spindle, and MO4 will be start spindle as well, but they are at two different directions. One is the clockwise, the other one is counterclockwise. And MO5 is simply a spindle stop. So MO6 is execute the tool change. So this is a table that you can always refer to when you are doing some G-code programming. Someone may ask, why do I have to learn this? It's because when you are doing program, you need to understand that how the machine tool works, as well as you need to know how how to edit the program, because sometimes you might have to make some little bit of modifications of the operation, and then to either to fix the code or to edit the code to make some modifications of the machining based on different scenarios. So that's why you need to understand the G code and how they works, so you know where to edit, right? Where to manipulate the machine or the program. And these numbers, tables are very important places that you need to come to, when you look at this, when you look at this program, and okay, but this is what this line of code is telling the machine to do what, right? So. As I just mentioned before, usually, when we are doing some of the programming for CNC, it's more computerized right now. But in a long times ago, for example, when I was learning, CNCs, actually I learned manual programming. So manually, you use a pen and write what is the G code to do what. Sometimes, those kind of programming can be really, really long, like hundreds of lines or thousands of lines that really time consuming. But later, people started to create those kind of softwares or programs that you can let the computer to generate the all these G codes for you, and that saves a lot of time. And so how does it work? And so usually, when we have a part, first we design the part, in the CAD software, and then we use some of the software that's called CAM software, computer-aided manufacturing CAM software, to define the tool path. But basically, to define in the software how the machine tool should move, right? To generate those kind of tool passes and also the operation sequences. Then once you have that kind of simulation or have that model, the computer will automatically generate all these instructions, right? So which is the codes. So this is what happens in the computer when the computer receive all these information, the tool passes, and also then the feed and speed, all this information. Then the computer will, based on the information provided, it will do some translation, use some algorithm to do some color offsets, those kind of calculations. Then will generate the code, CNC code, right? This is CNC code. Cutter offset, I actually just explained that before. Because for each of the cutter, it's with run, right? It's a round shaped, right? It's a round shaped, circular shaped cutter. So when we are defining, what's the tool path, we are actually talking about the position from here to here to here to here. Not these points, okay? Not these points. Well, in this case, that's why we have to, when we are doing some programming about the codes, we have to acknowledge that the tool actually has a radius that we need to make this offset. So we need to make sure when you are programming, we are actually telling the machine tool is actually doing those kind of cuttings, right? So this is what we want. This is called offset. And computer programming, and we start with this CAD model, and then we use a CAM to generate operations, select cutters, select different tools, define the tool paths, and do simulations, and then we generate the G code here. Some examples of the machining cycles. For example, there's a pocket milling. We can use the mill machine to mill a pocket. We can do the contour turning. So this is a turning. Watch that in video as well. We can do the facing operations. So we get a material. You can see this is a new faced a new surface, right? And also we can do the threading as well, on a turning machine. And so after we generate the code, you will be that will be uploaded to the computer system on the CNC machine. At that time, it's still the operator can actually edit the program as well. After you upload it, you can go through all the lines of codes and you can make some modifications. And sometimes if it is very simple operation, the operator can actually only program the code on the CNC computer itself, because it does not require a lot of programming, maybe only several steps. Then that's a lot easier, so you can do that on the CNC machine. But that's only fit for some of the very simple operation of small shop, or some small shop that cannot afford a professional program staff. All right, now let's look at one example of the CNC machining. So the idea is you need to you can write very simple CNC programming after this class, and also understand how those letter prefix, and also how the programming how the G code program works. Okay. Now let's first read this problem description. It's a drilling 3 holes in the sample part shown in the figure. So basically we are only drilling 3 holes. You can see there are actually 4 places. We are only drilling 3 holes. The 3 holes are 70-30, 70-30, this, and 70-60, this one, and also 120 and 30. So this hole. So the outside edge of the starting work part has been rough cut and are slightly oversized for subsequent profile milling. For the drilling sequences, the part is gripping in place so that the top surface is 40 millimeters above the surface of the machine tool, right? Tool table, right? Machine tool table, to provide ample clearance beneath the part of the cold drilling. The XYZ axes are defined as shown in the figure. Okay. 7 millimeter diameter drill corresponding to the specified hole size has been chunked in the drill press. The drill will be operated at the feed. Now we have the feed. This is the drilling feed. 0.05 millimeter per revolution and a spindle speed of 1,000 revolution per minute. So at the beginning of the job, the drill point will be positioned at the target point located at x0, y minus 50, and z is 10. Okay. Now at the beginning, actually, the x is 0, y is minus 50. Now this is positive 50. It means it's somewhere, somewhere here, right? It's minus 50. If we extend that x-axis here, right, minus 50, and it's above it, right, above the surface. Right, it's 10 above that. And the program begins with the tool position at this target point. So this is a start point where the machine tool begins, right? And what do you want to do? It wants actually to cut or the drill the 3 holes, right? Drill the 3 holes. Now do we know the thickness of the holes of the workpiece? Yes, we know it's here, right? It's here. It's actually this part, right? So why do we know this is the thickness of the workpiece? Because in a coordination system, usually when we have a workpiece, what happens is, and we'll either usually when we define the coordinate system, we're gonna use the top surface, right? The top surface. Either this one or here, right, to define a coordinate. This will be the x, this is the y, and this will be the z. So in this case, now we can tell what is the z value for the lower end of this workpiece, which is minus 10 here, right? So we know the thickness of the workpiece actually is minus 10. So which means when you are drilling the hole, you need to make sure the machine tool actually go down to at least minus 10, right? At least minus 10. So this is an example. All right, now let's look at the solution. How does it work here? And we'll start with the first code, which is these are the sequences from 1, 2, 3, 4, 5 until 12. We have 12 codes here, and the first code is G21. G21 means it means input value specified in millimeters. So it means we are using the millimeters instead of inches, right? And the G90 means program in absolute coordinates. So, right, absolute coordinates means we are not using incremental. You need to tell the machine which coordinate system we are using. And G92 is specify the location of the coordinate of the axis. So G92 means we need to tell the machine where is that origin of the coordinate system, right? How do we tell that? By tell where the tool is at, right? By tell where the tool is at. For example, we have this workpiece located here, and we want to define the original point is here. So let's go 0, 0, 0, right? But now where is our cutting tool? Our cutting tool is actually maybe somewhere, right? Maybe somewhere here. So if I can define what is x, what is the y, what is the z here, then I will know where is this original point is, right? So this is what happens. So now the current cutting tool is actually x0, y minus 50, right? Z 10. Remember, why do we have this 0? What shows 0 50.0 is because we are reserving one digit for for 3 digits of numbers, right? So that's why. To negative 50, Z10. So we now know where this tool is at, and also we can define we know where is the original point is. And then the second line is G00 X and Y. So G00 means it's a point-to-point movement. So which means that we're gonna ask the machine tool to move to this point, right? To 70-30, right? 70-30, which is this position. We're gonna first ask the machine to move to this position. All right. So when the machine tool, you're gonna see Z is not changed, right? Z is not changed, which means Z is still 10 above the surface, 10 above this surface, right? So we do not have to specify what is the change of what is the Z. So because Z is not changed. And the third line is G01. So G01 means it's a linear interpolation movement. So this is a linear movement. We are not moving as a circular or a curve. We are doing the linear movement. And G95 means specify the feed, right? To tell the machine what is the feed, right? All right, G01 linear movement. We're gonna ask the machine tool Z minus 15. Means what? Means originally the Z is actually 10 above this surface, right? Now we're gonna keep the X and Y the same because we didn't specify anything about X, Y. We only specify Z go down to negative 15. So it means X, Y is still the same. We're only asking the machine tool to go down to negative 15. So this is negative 10. So which means we go to even even deeper, right? To drill the hole. And then meanwhile we tell the machine that what is the feed, what is speed, and also MO3 is spindle start the speed spindle. They are all happening at the same time. When you are starting spindle, spindle is moving at a certain speed and feed. Then after we drill the hole, what's going to happen next? Next, right? G01 is what is the linear movement, and gonna move Z back to the original height, right? Back to the original height, because we can't let the tool sitting there for forever, right? We need to, if we want to move to another position, we have to retract the machine tool to back to its original height, and then move to another position. And then what? And then G00 gonna move Y to 60, right? Keep the X the same, keep the Z the same. Only we move the Y to 60. Now move here, and then basically do the same. We're gonna specify the Z and also the F. Why don't specify this O3 again? Because during all these movings, the spindle is always spinning. It's always spinning, right? So that's why we're not tell it again. Same with the speed, right? Spindle speed. We already specified it's still spinning, so we do not need to do anything. So we only need to specify the Z and F, and then after this operation, do the same, retract, right? Retract drill from the hole, then same, move to another hole, and then do the same drill, and then retract. All right, so after that, right, after we retract, we already drilled the 3 holes. What's going to do next? Because in our original problem description, it says that after we drill the 3 holes, we're going to move to the tool's original point, so which is x0 and y negative 50, right? Z is still the same. It's positive 10, right? Then MO5 means we are what? It's a spindle stop, right? Spindle stop. M05. Stop spindle. Nice, because we're not doing any drilling anymore. Then lastly, M30 means we're in the program and then stop the machine. So this is how this kind of G code works in CNC machines. And this example is I think it's a good example to demonstrate how these G codes are composed of. And when you have a really long, like thousands of G code of the program, they are all basically the same idea. Simply tell the machine where to go, and then doing specify kind of some parameters, then tell spindle to do what and do what, right? If you are professional programmer for CNC, you need to remember all these prefix and also this common codes. If you are not, there is a tables. You can always go back and check those when you are doing some simple programming, or if you are working engineer as a manufacturing engineer, or working with CNC machines, you need to understand a little bit about that. All right, so that's all for today.